Hello everyone, hope you are doing good. Here I have come up with another experience on Databricks and Delta table design. The agenda is to understand what is Databricks Lakehouse design, the Lakehouse explained, layers of data processing, partitioning, G-order, few extra commands. Lakehouse is an open architecture that combines features of data lake and data warehouse to deliver the reliability, governance, and performance. Data warehouse where we get data from multiple data sources, create facts and dimensions. So in summary, if you see here, we have data is coming from multiple sources, different kinds of sources. Data is stored in Azure Data Lake Store. On top of it, we have a Delta Lake. Lakehouse is kind of a data warehouse built on top of low-cost storage. Why do we need a data lake architecture? Or what is the advantage of a Lakehouse? It supports transaction support. So previously we used to store data in the data lake and it's just a storage. It doesn't offer the flexibility of transaction support. Multiple users, when they do data access, data manipulation, it doesn't support the transaction. Ensures consistency while multiple users read and write data to the data stored in the data lake. And another benefit of it is storage is decoupled from computing. This feature helps to scale the services based on the need. Since we have the storage decoupled, different storage service and different computing service based on the business need, we can scale out, we can scale up either storage or both, either storage computing or both the services. Flexibility. The common storage data formats like Parquet is flexible to various tools, languages like Python, SQL, R. This enables various teams, various skill sets, team members like data engineers, data scientists collaborate and build business specific data models. Diverse data process. It supports various data processes like batch, real-time, streaming services. It enables a central data platform which supports to build different kinds of applications to help business enable data-driven decisions making capability. Now, what is Lakehouse? If you have seen the earlier slide, the Lakehouse has the capability of data processing and it offers computing and storage. Also, the storage means that we can store data within the Lakehouse or we can store only the schema. And it has few layers, and the layers like bronze or raw, silver or trusted, gold or refined. Something new that this is how the terms are coined. It was the earlier practices as well, but the names are different. Example, previously it was called stage table, then EDW, then data model. So all the data in the traditional data warehouse, if you analyze, the data is coming from the multiple sources and stored into the stage layer where we store them in transient data stored there. And then the data is refined and we build the dimensions and facts, and then data model and cubes, data marts be built on top of that. In this case, the data is stored as is format from the different sources, and then the data model data is refined. A trusted layer is built or silver layer is built which has the data refined, and we create the refined we create the facts and dimensions, and then in gold refined, that's the layer where we have the business specific data models. Like we can create different views based on the different consumption units. Like we have a business unit called marketing, business units called sales. So we can have the data models specific to them. We can create there, and which is exposed to the outside world, and like different applications and reports, they can access the data from there. So in the layer architecture of this data process helps in identifying which user or which group of users accessing what level of data. In this way, we can add security to our data and governance. Like we can control who are the people or users accessing what kind of data. For an example here, we have data from multiple sources, and from there we load the data to the branch. Branch is nothing but all these delta tables will be created with having all the data from the Parquet files without any kind of partitioning or any kind of design change. It will be the schema will be the same. Then it will be refined, facts and dimensions will be created with some particular order or particular partitioning strategy followed. After that, it will be refined, and business specific models are created. Now we have seen that tables, delta tables, so how they are different from SQL tables. So if you just see the syntax here, create table is similar to the SQL table, create table, table name. We can specify here schema name also. If you do not provide any schema name, the default schema name is the default is the schema name. Just like in DBO is an SQL server, it is the default as the default schema. But we can create schema and we can specify there also. And if you see, there is two different types of tables are there. One is managed table and unmanaged table. The difference is that the location. In case of managed table, we do not provide the location. That means the data is stored, data and schema of a table stored or managed by the databricks. Whereas unmanaged table, the schema only is managed by the delta table, delta lake, or databricks, but the location we specify. That means we know where to store the data. It is not decided by the databricks. We decide and we keep that. So one advantage of that is that we can control the location of the data and we know where the data is available, and that same data can be read by other applications as well. And we do not need the cluster should be run in order to the we do not want cluster to be running instead when the other application access the data. But in case of managed table, the cluster need to run, otherwise the table data cannot be accessed by outside world. So that's the two difference. The performance wise, unmanaged table a little bit delays in case of DML operation as compared to managed table, because of these data location, and it is unmanaged, so performance little delay. But the advantage is that we do not need cluster to be run when it is read by other applications. Using delta is the command which helps to know that it is a delta table. But by default, database runtime 8 and above, we do not need to specify using delta, or by default a table is created as delta in the Databricks. So there are some details here regarding the partitioning. What should be the partitioning and how it is managed? The partitioning is how the data is physically partitioned or separated. So when we store the when they load the data to a table, if the table does not have any partition, then all the data will be stored in different files. They're only divided based on the files. But if you have a partition, their partition key, the entire file or entire data will be divided based on the partition key column. So that's how the partitioning, and the partition helps in improving the query the reading, query writing. So partitioning helps in that. So here's an example. There are uh, three partition by example. The first one doesn't have any partition. So if we can see the files, then we can see the files that in one folder, and they are snappy compressed. You can see them. But in the second one, which is partition by company ID, you can see that based on the number of companies, it creates separate folders, and under the folders, it will have individual files in it. If you see that another one is calendar year, where partition is by calendar year, the folders are created based on the number, based on the year, and inside the year folder there will be lot many individual files will be there, which stores actual data. So it is not always only once we partition the data our performance will improve, or always. We also need to specify the G order. It is kind of we specify how the data is stored inside the file and which order it should be maintained. Which keys in a table should be used as a G order. The order, we should analyze the attributes, the fields which are used as predicates, and we need to use those are the order by condition. And for partitioning, we should find the columns which are used for joining between two tables. That's the ideal ones. Data shuffling. So in Databricks, in Delta table, when the data of manipulation operations happens, since the data is stored inside a file, the file can have modified, unmodified rows. In case in the normal behavior, when you do a merge operation where it is matched, do update, when not matched, we do insert. It goes to a file, and if there are certain files are modified, certain not modified, still it will process entire file because entire file is processed there. Whereas low shuffle merge, which is available at runtime 10.3 above by default, in that case it will process only the modified rows. It will not process the unmodified rows. In that way, it has less overhead. So just imagine a file has only 10% data modified. In case of low merge, shuffle merge is not enabled. In that case, all 100% data will be processed. But in case of low shuffle merge is enabled, in that case only 10% data which is modified, only that are processed. So that's the huge benefit on that. Now let's say we are talking about different partitioning, different G order to improve the performance. Now how to identify which partitioning strategy, whether the ordering strategy which we have is really going to help us or not. Options like partition by few columns, and then see the behavior how they are working. So we so this is how we can so this is how we can find the performance of the partition. So once we execute a query, we can see the jobs, and we can see the SQL query plan. And in the query plan, if you go, and we can see the details like number of files read, how much time it spent for the scanning, how many groups read, how many partitions read. So it all depends on these characters, these statistics. So this will help us to identify how the queries are behaving, how many partitions it is reading, whether a partition by year is working well with less number of partitions reading and less number of time for scanning, or partition by company ID is behaving well. So that's how these are the things we need to analyze and come and finalize. This is the right strategy for partitioning and G-ordering. As we discussed earlier, is low shuffle merge. So when we do a merge query, files which are not modified will not process. So if you can see here, we need to see how many low shuffle merge operations happen, how much time it has taken, and you can see if our data is not processed at all in this case. So some of the best practices for optimize. So optimize is required for the tables where we do a lot of DML operations. So what it is kind of a re-indexing, or so that what will happen? It is whatever the orders or the partition data is movement here and there with a lot of DML operations. It just optimize just ensures the data is backed in proper shape, so that queries can run efficiently on that. So we should do the data optimization on periodically based on the type, based on the types of queries or operations happen every day basis. We can decide whether we should do it on daily basis data optimize, or maybe once in a week. So that is based on that we can take a decision on that. Now, but we're talking about a vacuum. Vacuum is nothing but an operation where it removes uncommitted old snapshots. So basically what is the snapshot? The delta table doesn't support. And it also supports a lot of concurrency by multiple users reading or writing data into the same file. And this is happening because of it creates a lot of snapshot files. So the lot of snapshots are created on the data set, so that people can simultaneously read and write data, and at the time of commit, whichever does first will be committed, and the later if it is not committed and return the old data, it will throw an error. So with the partition table, again it creates a lot of more snapshots. So if you compare the table with partition or without partition, the number of extra files created for the partitions are more. Over a period of time, it ends up with a lot of files created which may or may not be needed for the organization, and there are some kind of uncommitted files, uncommitted transactions which are still lying in the files. Now these snapshots of files or the data helps in time travel. Time travel in the sense means if we want to know what is the stage of data, what is the data in the table for a given specific period of time period, we can specify that and it will return the result at the time specified. So these snapshots help us to do that. So let's say we want to know what was the data in the table 2 weeks before. So we can specify the date, particular date, and it will give us the data from the table by that time. And this is possible because of snapshots. But if we do not want to have a lot many snapshots, we do not need to go back for longer history, then we can remove those history by vacuum, by executing a command called vacuum. So vacuum will help us to know how many files it is going to delete, how many uncommitted old snapshots are available in the system, and based on that it will delete them. By default it maintains 7 days of snapshots, but it is always best practice to use the command called dry run. So it will say that how many files it is going to delete. Fine with the result, then we can execute vacuum table name without giving it dry run, so it will actually delete them. So once we execute vacuum, so the time travel beyond the time period will not be possible because it has deleted all the snapshots. There are some extra commands. Let's say we create a view and we want to see the view definitions. This is how we need to create the view, execute the command. So create a table and the view name. And another challenge which we faced was by default always results 1000 top 1000 rows. But if you want to know more records, not just always 1000 rows, this is how we can specify. Here in this case we have specified 50,000 rows to be displayed as output window. So there are limits not just about the rows, it is about the buffer size. If the number of columns are less, then we can go for even 100,000 records we can show as an output. But in our case, the number of there are around 150 columns in the query output. So with the buffer size limit, it is allowing us to 50,000 only. Thanks for being with me till this time. Hope you enjoyed this video, and hope the information provided is going to help you. Please do share at the comment section. Please like and subscribe my channel. Thank you so much once again. Have a good time ahead.